Is the low frequency gain for our amplifier shown here. And to do this, we have a lot of notes here, but if we look at page 143, we can find out that this is a common source amplifier. And that's going to take us to page 147, where we actually get this notes right here. Now, we're going to look at page 92, where we get this equation right here. And we're going to come back to this, because this has a place right here. And then we also have more equation right here. So doing all this will actually be super simple on how to solve this problem. The first thing that we need to do is find our voltage gain. So what do we not know? Well, we don't know any of our G's. We also don't know our R naught. Well, these G's, we neglect the effect of channel length modulation for the modulation in body. That means that our GMB and our GDS are both 0. Now let's solve for our GM. Our GM, we're given this WL, we are given our K naught prime, and so what we're going to do is use this, as well as our ID, to solve for our GM here. Previously, we've done like our IC over VTP, but we don't need to do that for this because we could just plug everything in here. Now, if we plug everything in here, this is going to give us a G of M of approximately 9.53 times 10 to the negative 4 for this problem. We would have the square root of 2 times 40 times 10 to the negative 6 times 57 times our 199 times 10 to the negative 6. That's how we would solve that. So that's our G of M. Now let's look at our R naught. For our R naught, typically we've just plugged in our RD, but the explanation about it is right here, right? That's the shortcut to just plug it in and say it's like this, but we need to test this. Previously, we've just said since it's a low frequency voltage gain, it's right here, it's just going to be this right here. They're going to be equivalent. Well, the way we would test this to see if this is true or not is by looking at this right here. So we would say that our R naught is equal to 1 over RD. We have a plus 1 over, we have this R naught first, and this R naught is given to us right here. Now we have 1 over lambda times our ID. Lambda is not given here, so that means that this is 0. But it's not actually 0, it's approximately 0. So 1 over approximately 0 is going to be basically a 1 over let's say 1000. 1 over some huge number. This would give us 0, right? But if we take this, we multiply both top and bottom by the 1000, some big number, it's going to give us approximately infinity for this. And if we have 1 over approximately infinity, this is going to zero out, right? And we know that this is to the negative first. So that means our R naught is just going to equal to our RD. That's how we would prove this. And so now we can safely just plug this in. We can plug our RD in, 11.3 kilo ohms. We have our 1 plus, we have our GM, and we have our RS given to us. And so we can just take these and plug them all into this calculator. And that's going to give us approximately negative 3.28. So the answer for this problem is that our AV is equal to negative 3.28. That's how you go about solving for this problem, proving this down here, and doing anything like it.